Hello, so in today's video, we're going to look at binomial expansion. So what do we mean by binomial expansion? Well, examples like this that I've written on the screen here. So a binomial expansion is basically when you expand brackets with two terms in them. So there's one term here, there's one term here, you have two terms. So this is called a binomial expansion, as is this one here. Again, we've got two terms within the brackets. We're expanding these brackets. This is called a binomial expansion. If you had three terms, it would be called a trinomial expansion. And if you have the general case of n terms in an expansion, that would be called a multinomial expansion. So yeah, these are binomial expansions because we have two terms within the brackets that we expand. And you can have powers of any kind. You can have positive powers like these. You can have integers. You can have rational numbers. You can have negatives like this one here. That's what a binomial expansion would be. So let's look at the simplest case of a binomial expansion. Let's look at a binomial expansion like these ones here. So 1 plus x to the power is 0. Well, that's just going to be the number 1 because anything to the power of 0 is the number 1. I should really actually emphasize that x must not be equal to -1 here. If x were equal to -1, then that would mean that this is 0. You get 0 to the power of 0. That's not a well-defined number. But this one here, so 1 plus x to the power of 1, what would that be? So that's just going to be 1 plus x. Now 1 plus x is just the same as 1 plus 1x. So I'm just going to emphasize that this is 1 times 1 and this is 1 times x. You'll see why I'm doing this in a minute. Okay, so the next expansion, 1 plus x squared. So that's going to be 1 plus x times 1 plus x. When you expand your brackets, you should get 1 plus 2x plus x squared. And again, I'm just going to emphasize something. So I'm just going to emphasize that this is 1 times by 1. This is 2 times by x, and this is 1 times by x squared. Okay, so now we're going to go on to the next expansion. So I'm just going to put my brackets around here instead. Actually, I'm going to put the brackets around there. Okay, so the next expansion. So 1 plus x cubed. So that's just the same as 1 plus x. Let me write it here. So 1 plus x times 1 plus x times 1 plus x. If you were to do this expansion here, I'm not going to do it in full here just because I'm too lazy. If you were to expand the brackets, expand that, expand that, expand that, expand that, and then multiply your result by these two terms here, you should get 1 plus 3x plus 3x squared plus x cubed. That's what you should get when you simplify and collect your like terms. So again, I'm just going to emphasize that this is 1. I'll do this in red again. So 1 times by 1, 3 times by x, 3 times by x squared, and also 1 times by x cubed. Are you noticing a pattern so far? So if we think about what we looked at in the previous video, we looked at something called Pascal's triangle. Now, if we just circle these coefficients here, so 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. These are the coefficients in Pascal's triangle. So these were the numbers that we looked at in Pascal's triangle in the previous video. So actually, yeah, when we expand this 1 plus x to the power of an integer, a positive integer, we do get Pascal's triangle coefficients. So if we did 1 plus x to the power of 4, we should get 1 plus 4x plus 6x squared plus 4x cubed plus x to the power of 4. That's what we should get there. And again, our coefficients are the next row of Pascal's triangle. So 1, 4, 6, 4, and a 1 there. So yeah, we get coefficients of Pascal's triangle when we expand 1 plus x to a power of a non-negative integer. Okay, so yeah, this is what I've written here then. So the coefficients of the half term of the expansion 1 plus x to the power of n are the values in Pascal's triangle. So what I mean by that is if we call the number 1 there the 0th term, I mean, I know it's technically the first term, but let's just, for this purpose, call it the 0th term. So the 0 term is 1. The first term is n1. So n choose 1. Remember this n choose 1 notation we used for Pascal's triangle. So n choose 1 times by x. N choose 1. Sorry, n choose 2 times by x squared for our second term. Plus ... all these terms in the middle, and then plus our half term which is n choose r times by x to the power of r plus all the rest of the terms up to n choose n. Now, n choose n is just the number one. How many ways can you choose n things out of n things? Well, it's just one way you can choose those n things. So 1 times by x to the power of n, that's our n plus 1th term. So yeah, that's how we would expand the brackets for general case x plus 1 to the power of n, where n is a natural number. So n is a whole positive number. That's how we would expand these kind of binomial expansions. Okay, so yeah, so a general rule in which we can write this. So again, so 1 plus x to the power of n, where n is a natural number. This is the key things. N must be a positive whole number for this to be true. This is going to be the sum. So using this sigma notation for the sum. So we're going to sum our n choose r's times by our x to the power of r's, and we're going to sum that from 0 up to n. So sub in r equals 0, n choose 0 is just 1, x to the power of 0 is just 1, so we get 1 for a first term. Our second term is going to be r equals 1, so n choose 1, which is n, times by x to the power of 1, which is x, so we get nx as our next term. And then our next term, n choose 2 times by x squared, n choose 3 times by x cubed is our next one, so on and so on and so on, up to our final one, n choose n, which is, again, 1, times by x to the power of n, that's x to the power of n. So that's what we get there for our last term. So yeah, that's how we would expand these expansions. Now, how about something different? So how about how about something where we've got like a coefficient next to the x within the brackets? So how about 1 plus 2x to the power of n, where again n is a natural number, so a whole number, a non-negative whole number. How about this? Okay, well, 1 plus 2x to the power of 0 is going to be 1, unless x were to be negative a half, but let's just assume it's not. Then 1 plus 2x to the power of 1, that's 1 plus 2x. And then the next one, 1 plus 2x all squared. So again, when we expand these brackets, we're going to get, when you do the expansion, you should get this 1 plus 4x squared. And now what I've done in this color here is I've written it in a slightly different way. And again, you'll see why I've done this. So 1 is the same as 2 choose 0, which is again 1 times by 1. So that's where the first term comes from. The next term, 2 choose 1 is the number 2 times by 2x, the 2x that I've got from there. You would get yourself 4x. So that's another way we can write this 4x. Same with this one here. 2 choose 2 is the number 1. 1 times by 2x all squared. Well, that's 1 times 4x squared. That's where we get this 4x squared from there. So that's just another way. Again, you'll see why I'm doing this specifically for this case, because on the bottom with this expansion, 1 plus 2x to the power of all to the power of 3. Again, we get 1, same as 3 choose 0 times by 1. We get 6x. Which is the same as 3 choose 1 times by 2x. So 3 choose 1 is 3. 3 times 2x gives you 6x. Now 3 choose 2 is 3 again, times by 2x all squared. 2x all squared is 4x squared. 4x squared times by 3 gives you 12x squared. So that 12x squared is the same as that there. And then the last term, 3 choose 3 is 1. 1 times by 2x all cubed. That's going to be 1 times by 8x cubed. You get the 8x cubed there. Okay, so that's just, again, another way we can write these expansions. So again, you may see a pattern. It's exactly the same pattern with these Pascal triangle coefficients, but this time we're multiplying everything by 2x within like these brackets here. So rather than multiplying these Pascal's triangle coefficients by just x and x squared and x to the power 3 and so on and so on, we're multiplying them by 2x all squared, 2x all cubed, and so on and so on. So yeah, so if we've got something like this, so if we've got 1 plus ax all to the power of n, whereby n is a natural number, so a positive whole number, and also a is some value, so again, some non-negative value, not non-negative, some value which is not equal to 0, just not equal 0 value, you would get this. You get the sum of n choose r times by ax all to the power of r. So again, your first term is going to be 1 because n choose 0 is 1. Ax to the power of 0 is 1. 1 times 1 gives you 1. Your next term is going to be n times this ax in there. Your next term is going to be n choose 2 times by the ax in there all squared. And then it's going to be n choose 3. Let's actually just write this here just to be clear. So our next number in the sequence or on the expansion is going to be n choose 3 times by ax cubed, and then plus dot 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 until we get up to our final expansion, until we get up to this here. Sorry, this should be an n here. Sorry, forget this. This should be ax to the power of m. And again, technically times by n choose n, but n choose n is just the number one, so we don't need to bother writing the number one there. And again, n choose 0 technically there, but n choose 0 again is the number one. We don't need to bother writing that there, so that's fine. Brilliant, yeah, so that's that. So how about then if we want to expand a plus bx to the power of n, where again, a, b, non-zero, and n is some natural number, some positive whole number. How about this then? So what I did here was I said, okay, well, let's factor out this a from the brackets there. So let's factorize out the a. So if we do this, we're going to get a on the outside of our brackets, and then 1 here because a times 1 gives us the a there. And also what we're going to get here is going to get a times b over a, because a times b over a gives us just b, because the a's cancel out. So then you get this here, this factorization here. So a times 1 plus b over a x all to the power of n. So when we do this, then this is just the same as an to the multiplied by 1 plus b over ax all to the power of n. Now we know that 1 plus ax to the power of n gives us this result here, this expansion here. So 1 plus b over ax to the power of n is going to give us this expansion here. So this sum here. So it's going to be this an there, multiplied by the expansion for this 1 plus b over a times x to the power of n, which would be this expansion here. So in other words, it's going to be a to the power of n multiplied by 1 plus n choose 1 multiplied by b over a times x to the power of 1 plus n choose 2 multiplied by b over ax all to the power of 2, and so on and so on and so on until you get to n choose n, which is again just the number 1. So we'll just write this here just to be clear. N choose n, number 1, times by b over a times x to the power of n, and that would be our binomial expansion with an expansion like that. So if you had like 2 minus 3x to the power of 10, obviously your n value would be 10. Your a value would be the a value that I said. I can't actually remember the numbers. I think it was 2 minus 3x to the power of 10. So a would be 2. Your b would be minus 3. And then you just plug these into this result here. You don't need to actually learn this formula, but as long as you're happy with how you derive this formula, that's the most important thing. So in conclusion then, if you've got a and b, which are real numbers that are not equal to 0, so non-zero real numbers, and also if n is a natural number, so a positive whole number, you'll get this expansion here. So when you expand a plus bx to the power of n, you get this result here. So as an example, if you've got like, again, 2 minus 3x, let's just do to the power of 4. So this is going to be 2 to the power of 4 multiplied by 1 plus 4, because that's the n value. So let's just make this clear. In this case here, a is 2, b is minus 3, and n is going to be 4 in our case. So this is going to give us 4 times by minus 3 over 2x plus n choose 2. So 4 choose 2, that's going to be the number 6, I think, the number 6. So we get 6 multiplied by b over a, so 3 over 2x all squared, and then plus, again, 4, because that's going to be n choose 3. 4 choose 3. 4 choose 3 would be the number 4, multiplied by minus 3 over 2 x to the power 3, and then lastly n choose n, so 4 choose 4, that's the number 1, so that's going to be 1 times by minus 3 over 2x all to the power 4, and that would be our expansion. So we would get 16 times by 1, and then minus 1.5 times 4, that's going to be minus 6x. Then minus 9 over 2 all squared, well, minus 1.5 squared, that's going to give us 2.25, then times that by 6, we're going to get minus 13.5, so that's going to give us a minus positive 27.5, positive positive 27 over 2, positive 13.5 x squared that, and then next we're going to get so minus 3 over 2 all to the power of 3. That's going to give us minus 27 over 8. Times that by 4, we would get a minus, again, a minus 13.5, so minus 27 over 2 x cubed. And then lastly, if we do the next one, so minus 3 over 2 to the power of 4, we get a positive 81 over 16 times by x to the power of 4. 81 over 16 times by x to the power of 4, all multiplied by 16. So you just expand the brackets finally, times 16 by all these numbers there, and that would be your expansion for this expansion here. So that's, again, another way that you can do these binomial expansions. You can just use that formula there, and you can plug that into the formula and get your results there. So yeah, that's the end of this video on how to do binomial expansions when your number in the power is a positive whole number. That's how to do these expansions.